Prepare to be captivated and transported to the cutting edge of space exploration as we delve into the mind-boggling world of the James Webb Space Telescope, JWST. Buckle up and get ready to embark on an interstellar adventure filled with mind-blowing facts that will leave you in awe of the mind-bending technology, mind-boggling discoveries, and mind-expanding possibilities of this monumental astronomical marvel. So get ready to have your imagination launched into orbit as we uncover the jaw-dropping facts about the James Webb Space Telescope that will leave you starry-eyed and yearning to explore the celestial wonders that await us. Here are the 10 facts. 1. The biggest space telescope in history. Launching in 1990, Hubble Space Telescope was the largest space telescope in history. However, James Webb Space Telescope, JWST, took over this record in 2018. At the size of a typical school bus, Hubble will be dwarfed by JWST's tennis court size. Not to mention, JWST's 21.3-foot wide primary mirror will collect tremendously higher amounts of light than Hubble's 7.9-foot primary mirror. Number 2, a golf ball-sized amount of gold coats just mirrors. JWST will observe some of the universe's most distant objects. As a result, in its more than 13 billion-mile journey, the object's light becomes heavily shifted toward the red side of the electromagnetic spectrum. Therefore, JWST's primary mirrors are plated in 24-karat gold. Simply put, gold reflects red light better than nearly any other metal. Ultimately, this allows JWST's mirrors to be 98% reflective compared to the typical 85% reflectiveness of standard mirrors. Number 3, unlike Hubble, JWST will not be serviceable during its mission. To either upgrade or repair Hubble throughout its nearly 20-year stint, several manned missions visited the telescope in space to carry out operations. However, Hubble orbits Earth at a measly 340 miles away. In comparison, JWST will orbit at just under 1 million miles out, 940,000. As a result, no missions are currently planned to perform any service or repair operations on the telescope. Number 4, JWST can see a single penny 24 miles away. The sharpness of vision, or angular resolution, is everything for space telescopes. And JWST is no slouch in that department. The telescope could see a U.S. penny from around 24 miles away. Put another way, JWST could resolve a football from around 340 miles away. Number 5, JWST will be able to detect water on exoplanets. Today, we discover planets orbiting other stars by monitoring slight dips in the star's light as the planets pass in front of them. Furthermore, we can read unique signatures in the light, telling us a planet's chemical composition. Finally, the strongest and most readable signatures occur within the infrared spectrum. Therefore, JWST's state-of-the-art infrared instruments will help us locate new planets and accurately identify the presence of important things like water. 6. With active cryogenic cooling, Webb will get all the way down to till 7K. The low temperatures reached by passive cooling in the 36 to 50K range are completely sufficient for the operation of all of Webb's near-infrared instruments. This includes 3 of its 4 major science instruments: NIRCam, the near-infrared camera, NIRSpec, the near-infrared spectrograph, and the FGS/NIRSS, fine guidance sensor/near-infrared imager and slitless spectrograph. They're all designed for operation at 39K, well within the range of passive cooling. But the 4th instrument, MIRI, the mid-infrared imager, needs to be cooled even farther than passive cooling can get you, and that's where the cryocooler comes in. Helium only becomes liquid at about 4K, and so by attaching a liquid helium refrigerator to the MIRI instrument, Webb scientists can cool it down to the needed operating temperature, TELDS 7K. The longer the wavelength of light that you want to probe, the cooler you need to get your instruments, which is the primary reason for most of the design decisions that went into the James Webb Space Telescope. 7. Unlike NASA's Spitzer, which transitioned to a warm mission when it ran out of coolant, James Webb should maintain its cold temperatures for its entire lifespan. The liquid helium that keeps James Webb actively cooled, in principle, should never run out. It's a closed system. However, as anyone who's ever worked in experimental physics can attest, leaks inevitably happen, no matter how well you safeguard against them. Designed for a 5.5-year mission, at minimum, with the possibility of a decade or longer under the most optimistic circumstances, Webb shouldn't run out of its cryogenic coolant if it lives up to its design specifications. Travel the universe with astrophysicist Ethan Seville. Subscribers will get the newsletter every Saturday. All aboard. Fields marked with an asterisk are required. 8. Although it wasn't designed to be serviced and upgraded, it could potentially be robotically refueled to extend its life. It seems a pity that Webb's lifetime, after all of this effort, will be so finite. Sure, 5 to 10 years is enough time to learn a tremendous amount about the universe, meeting a large number of ambitious science goals and opening ourselves up to the possibility of serendipitous discoveries that we have perhaps not even yet imagined. But after all that we've been through with development and delays, it seems insufficient that James Webb will have a life that's cumulatively shorter than the full extent of its time here on Earth. 9 JWST's science instruments will function at close to absolute zero. Simply put, the colder the temperature, the fewer atoms move. Ultimately, at absolute zero, the coldest possible temperature, minus 459 OF, atoms essentially stop moving altogether. Now, JWST observes light in the infrared spectrum. However, JWST itself emits infrared heat, which can interfere with precious data. As a result, the high-tech instruments aboard JWST will operate at nearly absolute zero to decipher data accurately. The Space Telescope's primary operating temperature is only 50 degrees above absolute zero. Number 10 JWST launches far, far away from home. Launching in an Ariane 5 rocket provided by Europe, JWST will blast off from a European spaceport near French Guiana in South America. Plus, this launch location happens to be very close to the Earth's equator. Simply put, the Earth spins considerably faster toward the equator. Ultimately, this increased spin will provide an additional fuel-free boost for the Ariane 5 rocket carrying the telescope. The world's most reliable launch rocket and a free booster are not bad. As we reach the culmination of this exhilarating voyage through the captivating world of the James Webb Space Telescope, JWST, we are left in awe of the technological marvels that await us in the depths of space. This ambitious endeavor, poised to revolutionize our understanding of the universe, represents the pinnacle of human achievement and the insatiable thirst for knowledge that propels us forward. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.